Welcome to Study Loop.
Question 20 in chapter 22 asks us why the physical properties of D2O are so different from H2O. So what we need to think about when we're answering this is what's the difference between really deuterium and protium. Now, deuterium is just a special way of expressing this isotope of hydrogen versus protium over here. And this is the AZX notation. So this is the mass number, atomic number on the bottom, and then the atomic symbol. And so the thing that should come to mind here is that the mass of deuterium is roughly twice that of protium. And that's a big deal. If you consider another pair of isotopes, say chlorine. If we look at chlorine, we can look at chlorine 35 and chlorine 37. Chemically speaking, these two aren't terribly different from each other. And the reason for that is that the masses are roughly similar. But a lot of chemistry takes place via the transfer of hydrogen atoms. And so when you double the mass of that atom, you're going to do things like affect reaction rates. You're going to affect things like intermolecular forces. So really, the key thing for the difference in chemical properties between D2O and H2O is the mass. So let's look at the options that we have here. And the four options that were given for why the physical properties are different are that deuterium has a different electron configuration, which is not true. It is simply an isotope, and an isotope, by definition, is just a different mass, a different number of neutrons. So it can't be A. If you look at B, it says that deuterium is radioactive. It requires a little bit more in-depth understanding to know whether or not this is the case. But deuterium is not radioactive. Tritium is. That is to say, deuterium is not. But tritium is, and that's used in a lot of kinetics studies, actually. So it's definitely not B. Whoops, a little bit of a typo there. Deuterium forms stronger bonds with oxygen than H does. That is not the case. Because again, we're not affecting the electronic structure, really. All that we're doing is making it more difficult to add and remove that deuterium. And D, finally, is that deuterium is much more massive than hydrogen, and that is indeed where the difference comes from. Proportionally, it is twice as heavy.